Everybody's heard of the Fibonacci sequence. However, what you might not be aware of is that this sequence appears all over the natural world. Whether this be the petals on flowers or the branches on trees, the Fibonacci sequence is everywhere. Did you know that there is actually another mathematical feature hidden within the Fibonacci sequence, accounting for its prevalence in nature?
This feature can be found by writing out the terms of the Fibonacci sequence and then dividing each term by the previous term. For example, the fourth term divided by the third term is 3 divided by 2, which is 1.5. By continuing this for each consecutive term of the sequence, you create another list of numbers. This new sequence oscillates and converges to a value between 1 and 2. As the sequence tends to infinity, this value tends to phi.
Phi is a mathematical constant approximately equal to 1.61803 that is used throughout mathematics in the golden ratio, which is 1:phi. The golden ratio has been studied by mathematicians since Euclid and can be found in nature and geometry.
The value of phi can be derived by drawing a line split into two segments with lengths 1 and x, where x is greater than 1. The ratio of the longer length to the shorter length is the same as the ratio of the whole length to the longer length. This ratio is equal to the golden ratio. Using our values of 1 and x, we get that x over 1 equals x plus 1 over x. We can then multiply both sides of the equation by x and use cross multiplication to form a quadratic equation. X squared minus x minus 1 equals 0. The next step is to use the quadratic equation to find the values of x that satisfy this equation. These values are 1 plus or minus the square root of 5, all divided by 2. X is a length, so the negative value is discounted, leaving x equal to 1.61803, which is equal to phi.
The golden ratio is thought to be the most beautiful ratio. We decided to test this for ourselves and conducted a survey, asking students at our school to choose their favourite rectangle from a selection, each with a different side length ratio. Each rectangle was given a colour and participants put the corresponding coloured paperclip in our results box. After asking 100 students, we calculated the results. The green rectangle was the clear winner, with 53 out of 100 people choosing it as their favourite. Next, we calculated the side length ratio of each rectangle and compared it to the golden ratio. With a side length ratio of 1.7, the green rectangle is closest to the golden ratio, supporting the theory that it's the most beautiful ratio.
The prominence of phi in nature could be why we find it so visually appealing. Thank you for listening. We've been Nicola and Alex Goodwin.